Now another lesson, lesson 39. This will be useful for doing your practical, in your school. Uh, to find the focal length of a convex lens by displacement method. What is the principle? The principle is if the distance between the object and screen, this is a screen, is greater than 4 times the focal length, then for two different positions, this is one position, this is another position, for two different positions of the lens, there is a sharp image of the object on the screen. So let us discuss and analyze. Now here is the object, this is the lens, the first position of the lens. The lens has shifted to this side by a distance x, the second position of the lens. For this position, there is a image of this object on the screen, a sharp image. And for this position also there is a sharp image. Let this distance from here to here is a, from here to here is x, from here to here is b, and the distance between the object and the screen, is capital D. Now look, it is interesting to note that when the lens shifts from here to here, and when this distance is same thing as this distance, that is if this is a and then this is also a, then there is a second image, there is an image due to this position. In that case, this distance will be same thing as this distance. Now from the figure, a plus b, a plus b is equal to, from this point to this point, that is capital D, make it equation 1 for the first position of the lens. For the second position of the lens, now look, b minus x is equal to a, that is the second equation. From this I take x to that other side, right hand side, so b becomes, so, and bring a to this side, so b minus a becomes plus x, equation 3. Now add equation 1 and 3, add these two equations, 1 and 3, a plus b, b minus a, d x. This on simplification, a cancels, 2b is equal to d plus x, so b is equal to d plus x over 2. Put this value of b in equation 2, so b, that is d plus x by 2 minus x is equal to a. So take LCM, so d plus x minus 2x, 2 comes to this side, becomes 2a. Now x minus 2x is minus x, so 2 comes to this side, so d minus x over 2 is your a. Now apply the lens formula. Now we know for a lens, 1 over focal length is equal to 1 over image distance minus 1 over object distance u, v image distance. Focal length, I have to find out this, so I don't need to put any sign convention. So is equal to 1 image distance. Now look, for the first position of the lens, the image is on the screen. So the distance of the image from this point is from this point to this point, that is same thing as b in the direction of light, so b is positive b. This minus is same thing as this. Then object distance, for the first position the object is here, light is going this way, so from here to here, opposite to the direction of light, is the object distance a, that since it is opposite, so therefore negative a. So now put the value of b, and this becomes positive here, and value of a. Now 2 comes over, so 2 over d plus x, 2 comes here, 2 over d minus x, LCM this into this. So this becomes 2d minus 2x plus 2d plus 2x. So 1 over f, same thing as this. Now this cancels, 2d plus 2d, 4d. A plus b into a minus b is a formula in algebra. So this becomes d square minus x square. So by cross multiplying, f is equal to d square minus x square over 4t. Now this so this is how you find out your focal length of a convex lens practically. Now a plus x. Now look. Now a plus x is equal to d minus x over 2. A plus x is equal to d minus x over 2. Now plus x, a is this, x is this. Now take LCM, so this becomes equal to b. Now at position 1, now the magnification, calculation for magnification. At position 1, when the lens is here, the magnification, let the symbol is m1, and magnification for a lens we know m is equal to just v by u. For a mirror, magnification was minus v by u. For this was for a mirror, this was for a lens. So magnification m1 is equal to v over u, that is b over minus a. For position 1, v over a. A is to this side, therefore negative a. At position 2, that is at this position. Now image distance is this. Image distance is a in the direction of light, and your object distance is this, that is minus b. That is minus b. So this is the magnification at the second position. This is the magnification at the first position. I multiply these two, m1 into m2. So m1 into m2 by multiplying, m1 is this, m2 is this, so is this. So a cancels, bb cancels, minus minus plus, so is equal to 1. So the product of the magnification m1 into m2 is equal to 1.